So this is the part B, wherein we're going to discuss now the basic arithmetic instruction. So all in all, this will teach you on how to, do some addition, subtraction, multiplication, and then division. And then a little bit of a jump, okay, function, jump, and then a conditional jump. And one short example, I think. Yeah, one example of a compare. Okay, so all in all, we have a total of like 3 topics or 4. Anyway, this will be just a quick discussion since this module is quite easy to understand. So in here, we're going to talk about addition and subtraction first, or add and sub for the MU886 or the times 86 assembly language. So here is the syntax for the addition. So add and your first operand and then your second operand. Okay, just follow that one. If you want to subtract, then just change the add into SUB or sub. Okay, so in here, the second operand is added or added to or subtracted from the first. So same criteria, whatever you guys have learned in our previous modules, it's always from right going to left. So this operand 2 will be added to your operand 1, or this operand 2 will be subtracted to your operand 1. Okay, so I hope we're clear with that one. So we just have some guidelines here. So operands must be on the same type. So both should be bytes or both should be words. Okay, if other type, then it should be also the same. So other than bytes or words. And then first operand may be a register or data item memory location. So if you don't know what is a register or data item, so you can go back to our previous modules. So with that, you will learn about register data or data item or memory location. And then second operand may be a register, data item or a memory location or immediate. So the only additional thing is the immediate. So it could be a decimal already or a hexadecimal character already. Like for example, this is an immediate. This is an immediate. This is an immediate. So immediate character. So it is not in the form of a register or any kind of variable. So it's a straight value. Okay, that's what we mean by immediate. And then 2 data items as first and second operand not allowed. So one should be, introduced first, and then the other one can be a data item already. So 2 data items as first or second operand is not allowed. Okay, so we have this example right here, a very simple example. So again, the that model small, that stack 100 each, that the that code up to this point is the default syntax already. So we can just copy that one as it is. And then here's now the the new thing when it comes to addition or subtraction. So we have to declare a variable, say move DL, and then it has a value 4, and then we're going to add a value of 2 on that DL. So just add DL and then 2. So we have here your first operand, and then this is your second operand, and then this is your operator. So we're adding 2 to that previous line or that deal. So 4 is a result, of course, 4 plus 2 is equals to 6. Are we clear regarding with this one? Hello? Are you guys able to follow? Okay, again, first operand, this is our operator, which we're going to add, and then this is our operand. So in here, we have another, let's say, function wherein we want to add, okay, another value on that previous value of DL. So just put this one, add DL, and then 48. So from 6 plus 48, it will give us a value of 54. However, if you guys are going to Ascii, na lang. Mabilis. Just do take note that the one that it will display is the character, okay, not the decimal computation or the integer computation. Where is that one that I'm always using? Let's try this one. Is it clear? Maybe we can use Ascii. We can use the converter. Small hexadecimal. Why is it here? It's T. See, this one is quite blurry. Let's try to find a clearer copy. This one is not complete though. 48, 49, 54. It doesn't have a label. We need the one that has a label. This one. Okay. So this is the decimal computation. So 6 plus 48 is 54. But the one that it will display is the character, which is equals to 6. So let's not use that one. So let's try to redo this one. And we'll see what is the result of this example. Okay. So let me know if ever I mistype a word or a letter. I can correct it right away before running our program. So move EH is just an interrupt to display the character, display the result, and then force CH to end our program. That code move EX of data. Okay. So in here, as you guys can see, it gives us the result of 6. Okay. So not 54. Okay, because it always displays the character. Okay. So are we clear so far up to this point or up to this line? Well, actually, that's already it. You know, we've already finished the entire program. So were you guys able to follow? Let us give an example.
Yes, sir.
So let me know if ever you guys have a question or concern or clarification, okay? So in here, this is for the add and subtraction. Okay, let's try subtraction because we don't have an example for subtraction, okay? So instead of add, we'll make this one subtract. So 4 minus 2 is 2, and then we'll add, or let's subtract another one. So 4 minus 2 is 2, and then minus 1 again is 1. So in ASCII code 1 is, well, it's actually a start of heading. So this is not a displayable character. So maybe we can come up with the result of maybe 46. So I don't know what this one is, but it seems that this is an asterisk. 46. Let's try 46. So how are we going to come up with 46? 50 minus 2 minus 2. That is not a asterisk, but this is a dot. I'm not really sure if it's really dot. But yeah, it seems that it is really a dot. What about 45? So that is negative, I think, or minus sign. 45, let's deduct another 3. So 2, minus 2 is 48, and then minus 3 is 45. So yeah, we'll display the negative sign or the subtraction sign. Okay, so yeah, that's how simple it is to do a addition or subtraction in assembly language. All right, so let's proceed to the next one. So we can also add, via increment or via decrement. So increment will add 1, and then decrement will decrement, of course, or will reduce or will subtract 1. So let's redo this example. So everything is the same except for this one. Move BL4, add BL2, and then add BL48. So while I'm doing this one, you can also do this one on your own, terminal. So you can also verify if it's really correct or no. And add BL48. And then we're going to increment or add another 1 or plus 1. Then we'll display, and then from here, and decrement, and then display again the results for each. Okay. So there is just a note right here that outputs would be on the same line. So this is the first output. Where's that one? This one, it will display 55, which is equal to 7, and then it decremented by 1. So 54 is equal to 6, I guess. Okay. So I'm not really sure if you guys can see this one, but you can open a new tab and then check what is the value of 54 in character in ASCII code. Okay. So let's try this one out. Oops, why is it 3? Okay, let's see. 4 plus 2 is 6, plus 48 is 54, plus 1 is 55. And 55, 7. But why is it showing 32 for 3 and 2? BL, sad BL. So let's verify everything. Yeah, still 32. Move BL. This one should be add, not subtract. Okay, so we wasn't able to change that one. There you go. So we now have here 7 and then 6. So 7 for the 55 and then 6 for the 53. So were you guys able to follow this one?
Yes, sir.
All right. So let's proceed now to multiplication. So in here we have mule and I mule. Okay, mule for the unsigned numbers, and then I mule for the signed numbers. But in most cases, we'll only be using mule since we only have, or in most cases, we only use unsigned numbers. Okay, except if you're going to use signed numbers, then you can use I mule. Just change that mule or just add I before the mule or I mule. Okay, so here is the syntax: so mule and then the operand, and then I mule for the assigned number and then operand. So for byte operand, processor assumes that it will be multiplied by the value of EL. And then for the word operand, processor assumes that it will be multiplied by the value of AX. Okay, so as you guys can see, it follows this format. So byte is multiplied to EL, and then word will be multiplied to EX. Okay, so just follow that syntax, okay, because that is where it stores the multiply or the product, okay, of this result, this multiplication. So it's always use AL or EX. So we have this example right here. So move EL, so we have an initial value of 2, and then move BL is equal to 3 or 3, and then multiply BL. So again, this one is always assuming that the second operand will be multiplied to AL. So mul BL, so it already knows that 3 will be multiplied to our EL. So 3 times 2 is, of course, 6. And then we have another operator here, which is add. So 6 plus 48 is equal to 54. So 54 is what? 6. So 54 is equal to 6. That is what we are expecting here. So let's try this one out in our own assembly emulator. So we have here move BL into BL, and then this one is move BL followed by 3. So 2 times 3, and then this one is multiply BL, BL 38, move BL. So in here, whatever is the value of your DL, okay, so it will be displayed in our EL, okay, or it will be stored in our EL. So we have to get the value of EL, and then we'll store that one in EL, okay, and then will be displayed by this line. So let's try. Oops, why is it different from what we are expecting? Did we miss something? Move EL. This one should be 2 and then 3. 48, 3 Okay, let's try this one more time. Why is it still different? Did we miss something? Move each, first H, move each, little H, move DL. It's decrementing right here. And we have 2 display. We should only have 1. Move BLAL. See. I think everything is same now. Oh, why is it so different? What is wrong? Move EL, move BL, multiply BL, add BL 48, move BL BL, move H here to H, in 21H, move H percentage, in 21H. Why is it different? 55. Move H, 0H, in 21H. Does anyone knows what is wrong with our code? That code a bit smaller. And then end. Let's try to open a new one. Still give us the same result. Can you guys try this one on your own terminal?
So yung sa
There.
may add DL po, palitan nyo na lang ng add DL.
Let's do that one. Thank you, Mr. Martinez. So there you go. We now have a result of 6. Hindi ako nagbabasa ng chat Meron pala kayong mga chat. Okay, anyway, so thank you so much, Mr. Martinez, for noticing that one that instead of BL should be AL. Okay, so we now have here a value of 6. So yeah, that is it for the multiplication. So are we clear with this one so far?
Yes, sir.
All right. So let us proceed now to division. So this one is similar with the multiplication. So div for the unsigned numbers and an IDiv for the signed numbers. So in here, this one generates the result. So as we already know, so if we divide, could be, it could have a quotient and then a remainder, or a quotient only. But in most cases, of course, we don't know. Okay, so it could be a quotient and then a remainder. So the quotient will be stored in our EL, and then the remainder will be stored in our EH. So operand given is a divisor, while the divided is always assumed to be EX. So I know this one is quite confusing. So let's have an example. So this one is a single digit operands and output. So everything is pretty much the same up to this point. So here are the new things or the new codes. So move EL is equal to 6. This is the, let's say, the first number, operand 1, and then move BL is the divisor or the second number. Okay, so as you guys can already see here, we have 6 divided by 3. So we are already expecting that this 1 will divide the first number. And then move AH is a, let's say, 0. Okay, so this one should be always a 0. Okay, so we have to clear the AH. So clear AH, since div instructions takes AX as divided. So recall that AX is 16-bit, is compressed of EH, which is the, EH and then EL, which are both is 8-bit. So there's a need to clear the EH. Okay, and then we have here now the div BL. So all in all, we have 4 lines of codes in properly executing a division for this one. So 6 divided by 3, followed by this move AH, 0, and then div BL. So the rest could be, if you want to add more, if you want to subtract more, if you want to increment, decrement. So it is completely up to you. But in here, we already have a result of 2. Okay, and then you just need to add 48 because 2 in here is undisplayable. That is the start of text. So we want to see a display or a character. So plus 48. So that is 3. Yeah, that is 3, right? 2 plus 48 is 50. So 50 is equal to 2. Okay, that is the character that will be displayed on this given example. So let's try this one out. Move EL is 6, move BL is 3, and then here is the new one. We have to clear your EH or your EL and then EX, and then from mule to become division or div. Again, everything now is the same, I guess. So there you go. We now have the result of 2. So just note that all inputs and outputs and examples and activities must be single digits or 1 byte only. Other instructions for multiple digits will be discussed later in this course. So for now, we'll have these examples, these basic examples. If you guys will be needing 2 inputs, or let's say more than 2 input, okay, and then more than 2 output, then this will be discussed, or that will be discussed later on. Okay. So for now, are we clear with this given example? So it gave us a result of 2 or a character of 2. Hello? Are you guys still around?
Yes, sir.
Yes, sir.
So were you guys able to follow, or you guys need maybe a minute or 2 more minutes to have a read and we try to understand? All right, so I will wait. So just give me thumbs up once you are very good with this example. Okay, so thank you, Mr. Martinez. What about the others? All right, so it is now only Mr. Alburo and Mr. Bukat. Okay, good. What about Mr. Bukat? Okay, so maybe he's not here. Anyway, so let us proceed now to the sequence instruction. So this one will let you control the flow of your code for your program. So description of the order in which instructions in the program are executed. So this one involves the transfer of control to the address of an instruction that does not immediately follow the one currently executing. So we have two possible ways to do this one. Could be forward or backwards. Forwards, of course, execute a new series of steps. And then backward, of course, it's for straightforward. It will go back to the same step. Okay. So we have an example right here. Let's say jump L1, then it will skip some lines. So no matter how many lines it is. But I think this one has a limitation though. So jump is like maybe 10 lines of codes. It can skip that 10 lines of codes. But if it's longer than one, if it's longer than 10, let's say 10 or 15, I'm not really sure how many lines. So you could use LGMP. So LGMP stands for long jump. Okay. So this one is just a shorter range. If you want to jump a larger or a longer range, then you have to use LGMP or long jump. Okay. And that is for the forward, and we have here the backward. So we can go below, we can also go back at the top. So jump L1, then we'll go back to this label right here. Okay, so label in the code segment. So this is in markings within a code segment to control the execution of a program. So similar with variable, okay, it will go to that specific variable, or it will go to that specific line of code or function code. Okay, so label name, any valid name so that you can think of. So type could be far or near. So we have here the syntax. So this is the label name, and then the label, and then the type. Okay, so these are the inputs that you can change. Label name and then apply. And then here are the guidelines for naming labels. So it can be up to 31 characters. So that is the maximum characters that we can use in putting a name of a label. So use short names for a group of related labels in all the same area of the program, and use longer or descriptive names for isolated labels. But all in all, this one is still up to you. It could be short, could be long, or whatever you want. Okay, that is your own variable, your own label. And then of course, this apply the programming naming rules. The basics can start with a character. It's any character as long as it's the alphabet. Okay, so you cannot start with a number first. And we have here now the example for jump instruction. So it is an instruction that tells the processor to continue execution at the address given by a particular label. So we have here jump L40. So it wants to jump to this variable or to this label L40. So we have a total of three labels. So this is the first one wherein maybe it has 5 lines of codes. And then this is the second one, maybe this one has, let's say, 3 or 4 lines of codes. And this is now the L40. So as you guys can see, it will skip those lines and then it will proceed right away to our L40. Simple as that. Okay, this one is similar with the if condition. Okay, we're in. If it's true, then we'll go right here, right here. So wherever you want to go your execution line of code. Okay, so in here, just use jump to execute that one or to do that one. Okay, so are we clear so far for this jump L40?
Yes, sir. Clear naman po.
So this is for the forward. If you want to do the backward, then just put that one below and then many lines of codes, and of course it it can go back at the other time or wherever line of code that you want to go back. So we have here the conditional jump instructions. Let me just check if we still have enough time. So I think we don't have enough time anymore. So we only have maybe 10 seconds. So we'll just continue this one in part. So goodbye for now and see you guys later. So I will end this one now and then just wait for a new link. Okay, for the part 2. So let me just check if you guys are already in front of your computers. Just give me 3 thumbs up. So only one. It's not here. Okay, anyway. So let us continue now. So in here we have the conditional jump instructions. So again, a jump instruction that is executed only if a specific or a specified condition is true. So in here, if you want to make this one applicable, so of course we have to use conditional. So we have a lot of different conditionals or conditions. So we have here the not, equal, or and so on and so forth. But let's go over with this one for now. So where this xxx or this jxxx and then followed by the label name is an abbreviation for a particular condition. So in most cases, it's it only has a result of true or false. So for example, n is equal to not, okay, e is equal, G is greater than, and then L is less than, and then B is below, and then A is above. So you can use this one, let's say, jump if this value is equal to or not equal to or greater than or less than or below or above. So you can, use those conditions to execute a certain command or to jump to that specific line of code. So we have here the complete working jump commands or with conditional jump. So we have GE for jump if equal. G and E is jump if not equal. GL or same with the G and GE, but just use GL. So GL is jump if less than, and then GG is jump if greater than. GL is jump if less than, and then GGE is jump if greater than or equal. Sorry, we missed the equal. So GLE is jump if less than or equal, and then GGE is equal to jump if greater than or equal. Okay, and then we have GA for the jump if below, and then JB is jump if above. Okay, so are we clear so far with this one? So you can memorize this one if you want, but of course it's not required. So you can always go back to this module if you need something, see jump if equal or jump if not equal or jump if less, jump if greater, and so on and so forth. So we have here the compare instruction or CMP. So this is the compare two values. This is the syntax. So CMP followed by the first value and then the second value, comma, and then second value. So value 1 is compared to value 2. So in here, it's not from right to left anymore, but it's from left to right or from value 1 going to value 2. Or your value 1 will be compared to your value 2. Okay, so we have here the CMP instructions. So CMP AXBX. So this one will compare register with another register, and then we have here CMP EX and total. So this will compare a register with a data item or a memory location. So we also have CMP EX. This will compare a register with an immediate operand, and then of course vice versa. You can also compare the total and then to EX or the data memory, or compare data or the memory location item with a register, and then of course from data memory location or memory location item with an immediate operand or to an immediate operand. So those are the things that we can do when it comes to comparing things. So register to register, data item to register, vice versa, immediate to register, and then vice versa. Okay, so here are some restrictions when it comes to comparing. So compare two data items directly is not allowed. Compare two signed numbers or two unsigned numbers, so do not mix. So if it's signed number, just compare signed numbers only. If it's unsigned number, just compare unsigned numbers only. And then operands must be the same length. Okay, so we have here an example. So everything is the same until or up to this point. So we have these values. 4 for the DL and then 5 for the BL. So we want to compare DL to BL. So again, the BL, the first one will be compared to the second one, which is the BL. So if this is true, we have this condition right here. If this is true, this jump if greater than L2, then it will proceed to this L2. But if it's not, then it will just proceed to the next line. So if BL is greater than BL, then it will proceed, or this L2 will be executed, or this will proceed to be line 24. But if this is not true, then it will just go to line 16 or 17. Okay, and then we have another jump right here. So once it's done, adding and then showing the display, it will jump to the close section or close label. So where is that close label? It is right over here, so that it won't execute this L2 anymore. Okay, but if it proceeded to the L2, then there's no need to use this jump anymore, because of course it will proceed as follows. Once it's done with 29, line 29, it will now proceed to line 30. Then eventually it will execute this close label right here, this close line of code, and then of course it will close now, or it will end now the flow of the program, or the program itself. Okay, so upon inspection, will this jump to L2, or it will proceed to L1? So where will it go? Line 17 or line 24?
Line 34 ba?
24? Recheck, recheck.
Sure, dun ba sa line 31?
31? Dito muna tayo sa line 15. Okay, so it says here, jump to L2 if DL is greater than BL, else continue to next line. So meaning it will just proceed to 16. So if this is true, it will jump to 24. But if this is not true, give us a result of false, then it will jump to the next line, or 16 or 17. So while you are, trying to gather your thoughts and then trying to analyze everything, let me just copy so we can see the result. So just type your answer in our chat box. So you just type L1 if it will proceed to L1, or L2 if it will proceed to L2. There is no way that it will proceed to 31 first, the close, because we only have two possible results in here. Move VL. Move. Yeah. So again, it is not from right to left anymore. It is now from left to right. So operand will be compared to your operand 2. Compare DLBL jump. Each. Zero to each and one each. So what? What are your answers? Hindi ko itong mga to kumakain. Sino pa nandito? Miss Paklauna, are you around? Ito, wala to. Maybe kumakain to. Mr. Sarmiento? Yun. Okay, so what is your answer? Is it L1 or L2? L2. What about Mr. Bendingan? So maybe this Mr. Bendingan is also eating his lunch. What about Mr. Tanikala? Okay. Same way as one. He is also eating his lunch. What about Mr. Maaba? Nanghula ka na, Mr. Tanikala eh. Ay, tama. Nanghula ka na eh kasi hindi ka sigurado. Dapat sigurado ka. Yan. Answer with confidence. So I don't know with the others, but you guys are not, seeing your answer. But the correct answer is a 1. Okay. So this is false. Okay. As you guys can see, 4 is not greater than 5. So this will give us a result of false. So it will just proceed to the next line. Okay. So in here, it will just give us a result of 48, wherein 48 is equal to 0. So let's see. Oops, why is it 4? Compare DL to BL. Is DL greater than BL? No. 48. And then jump close. I see. My apologies. Okay, so we already have a value of DL right here, which is 4. So we added another 48. So 58 plus 4 is 52. 52 is equal to 4. Okay. But if it proceeded to the what is that one? If it proceeded to the L2, so the correct answer in here, or the answer in here is 5, because it incremented by 1 this previous result. Okay, so from 52 it will become 53, which is now equal to 5 in ASCII code. Okay, so there you go. The correct answer is L1. So it will proceed to our L1 or to the next line. All right. So yeah, that's pretty much it for this module. So in here you're going to have this laboratory. So you guys need to finish this one 2 weeks from now. So laboratory 3 is basic CMP and then jump instruction. So I think this one is quite simple. So create an assembly program that accepts 2 single-digit numbers from 0 to 9, num1 and num2. If num1 is greater than the display, then num1 is greater than num2. That is the one that we need to display. Well, if num1 is lesser than the display, then num1 is less than num2. So this is the one that we need to display. Otherwise, of course, if no greater than or less than between those two numbers, then just say that they are equal. Num1 and num2 are equal. Okay, so just compare those two inputs, use num1 and then num2. Then add another instruction for invalid input. So for example, instead of number, it inserted, or just the user inputted there an alphabet or a symbol. So you guys need to put a restriction, or just put a warning that you have inputted an incorrect input, or incorrect input. That's about it. Okay, so you should only put a number. Okay, so I hope we're clear with your lab number 3. For the lab number 4, this one's for ASCII characters. So create an assembly program that would check if the input character is a numeric character. Okay, so if it's numeric character, or if an alphabet letter, or a special character. So hint, each character has a corresponding decimal and hex values in the ASCII table. So use ASCII table for this one. So just check if the input is a numeric character, or an alphabet letter, or a special character. Okay. So are we clear with your lab number 3 and lab number 4?
Okay na po, sir.
What about the others? So if ever you have a question now, ask it now so that we can, solve your problem or concern. So don't be shy to ask. Still have, 3 hours. 1, 2, 3. Yeah. Hirap talaga pag tanghaling schedule, no? That is why you guys should eat your lunch before 11:30. So 11, so just eat it now, just eat it at that specific time so that once 11:30 came, so you're already ready. So you're not hungry anymore. Or you can eat while listening. But in most cases, I just saw right now that most of you are not in front of your computers, not really listening. So you're just here, what do you call that one? Hindi naman physically. You're just here via connection. Okay. But not really listening in front of your PC or laptop or smartphone. Anyway, so if you guys don't have any questions or clarifications anymore, that's about it. So see you guys next meeting. So goodbye and thank you guys for coming. So thank
Bye,
you.
sir.
Goodbye.
Thank you po, sir.
Thank you too.